I'm Anil Kumar. Welcome to my website, Global Math Institute. We are discussing questions from IB test paper, derivatives of logarithms and exponential functions. The question here is, for what value of a does the function y equals to e to the power of ax satisfies the equation second derivative of y plus 3 times first derivative of y plus 2y equals to 0. You can always pause the video, answer the question, and then look into my suggestions. Let's begin by finding the derivatives. We are given y equals to e to the power of ax. So the first derivative here is a times e to the power of ax. And the second derivative will be a square times e to the power of ax. Perfect. So these are the derivatives. Now let's look into the equation, which is second derivative plus 3 times first derivative plus 2 times y should be equal to 0. The second derivative is e to the power of ax, a square times e to the power of ax plus 3 times we have the first derivative, which is a e to the power of ax plus 2 times e to the power of ax equals to 0. Now from this we can always take e to the power of ax as common, right? So once you do that, you get a square plus 3a plus 2 equals to 0. Now e to the power of ax cannot be 0. Right? It's an exponential function. However, a square plus 3a plus 2 can be 0. So we can just factor this, right? So we'll equate, we can write this as e to the power of ax times, factoring this, we get a plus 3 can be written as 2 plus 1, right? 2 times 1 is 2 and 2 plus 1. So that gives us a plus 2 times a plus 1 equals to 0. Now, in this factored form, clearly we have two possible solutions. One is a equals to minus 2, and the second one is a equals to minus 1. So the question was, for what values of a does this function satisfy? So a, both are possible values. So we have two answers here. So we have the answer as a could be both minus 2 and a could be minus 1. So I hope that makes sense. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.